Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method part 2. Problem: solve y double dash plus y dash equal to 1 by 1 plus e power x or d square plus d of y equal to 1 by 1 plus e power x using variation of parameters method. We are given a differential equation of order 2. Given differential equation, y double dash plus y dash equals to 1 by 1 plus e power x, consider as equation number 1. We can write y double dash as d square y by dx square and y dash as dy by dx equal to RHS part. Now write d square y by dx square as capital D square y using the differential operator d, plus dy by dx can be written as dy equal to 1 by 1 plus e power x. Now take y common from the two terms of LHS, we'll get d square plus d of y equal to 1 by 1 plus e power x. Consider as equation 2, which is in operator form. Say f of d into y equal to some function of x, where f of d is d square plus d. And r of x is the RHS part, 1 by 1 plus e power x. Let's now write the homogeneous equation of equation 2. The homogeneous equation of equation 2 is d square plus d into y equal to 0. Consider as equation number 3. Now we'll find the solution to homogeneous equation using the auxiliary equation, and later using the solution of homogeneous equation we'll find the general solution of equation 1 and equation 2. Here 1 and 2 are same equations because the second equation is the operator form of equation 1. Okay. Now coming to auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 1, right? Let's replace the differential operator by m, so that we'll get f of m equal to m square plus m. Now the auxiliary equation becomes m square plus m equal to 0. Now take m common from these two terms, we'll get m times m plus 1 equals to 0. Now equate each factor to 0, we'll get m equal to 0, m plus 1 equal to 0. M equal to 0 is one root, from m plus 1 equals to 0, we'll get m equal to minus 1, which is another root. So from this we'll get 0 and minus 1, which are real and distinct roots to the auxiliary equation. The roots are real and distinct, right? We know that when two roots m1 and m2 are real and distinct, then the solution to our homogeneous equation looks like one constant into e power 1 root into x plus another constant into e power another root into x. So here we are taking C3 and C4 instead of C1 and C2 because I want C1 and C2 to appear in the last general solution. Right. Now coming to the solution of homogeneous equation. The solution to homogeneous equation is y equal to C3 e power 1 root into x plus C4 e power another root into x. This gives us C3 e power 0 plus C4 e power minus x. Since e power 0 equals to 1, so we'll get C3 into 1 plus C4 e power minus x, which gives us C3 plus C4 e power minus x. Therefore, y equal to C3 plus C4 e power minus x is the solution to a homogeneous equation, right? Now using this solution, we'll write the general solution of 1 and 2. just by replacing the parameters with some functions of x. Let y equal to, replace the constants or parameters with functions of x, a and b. We'll get y equal to a plus b e power minus x, be the general solution of 1 and 2, where a and b are functions of x, right? Now we can compare this solution or homogeneous solution with, or the solution to homogeneous equation with y equal to some c3 plus c3 into u plus c4 into v, or this with y equal to au plus bv. From this we'll get u and v, where u is 1 and v is e power minus x. See, here also you'll get u equal to 1 and v equal to e power minus x. Now we'll find a and b using, a dash and b dash using the formula a dash equals to minus v into r of x by u v1 minus v1, and b dash is given by u into r of x by u v1 minus v1. Okay. If you notice, we are having u v1 minus v1 in both the formulae. So let's begin with u v1 minus v1, and later we'll find a dash a and b dash b, and finally we'll write the general solution using y equal to a plus b e power minus x. v1 is nothing but derivative of v or v dash. u1 is nothing but derivative of u, or we can just write it as dv by dx minus v into derivative of u with respect to x. Now it is easy, right? u is 1 into d by dx of e power minus x minus v into d by dx of 1, which gives us 1 into derivative of e power minus x with respect to x is minus e power minus x minus e power minus x into derivative of 1 with respect to x is 0, which gives us minus e power minus x minus 0, right? Therefore, u v1 minus v1 is minus e power minus x. A dash is given by minus v into r of x by u v1 minus v1, right? Substitute v r of x u v1 minus v1, we'll get minus v is e power minus x into r of x. See, you're having r of x, which is a fraction, 1 by 1 plus e power x, right? So we'll write the formula as minus v by u v1 minus v1 into r of x for our convenience, so that we won't make anything mess. Okay. u v1 minus v1 is minus e power minus x into r of x, 1 by 1 plus e power x, which gives us 1 by 1 plus e power x, right? Or we can write it as, just write e power x as reciprocal of e power minus x. Okay, this gives us 1 by e power minus x plus 1 by e power minus x, which gives us e power minus x by e power minus x plus 1. Therefore, a dash equals to e power minus x by e power minus x plus 1. I am writing in terms of e power minus x because it is easy to integrate. Okay, so that it will be easy to find a. Okay, either you can leave it here, or you can write in terms of e power minus x. Now we'll find a using a dash. Here we have a dash equals to e power minus x by e power minus x plus 1. A dash is nothing but derivative of a with respect to x equal to e power minus x by e power minus x plus 1. So here we have to separate the variables. So I'll take the differential dx to RHS. I'll take this differential dx to RHS. Then I'll get dA equal to e power minus x by e power minus x plus 1 into dx. So here the variables are separable, so we can perform integration. Okay, we'll write this as dA equal to e power minus x by e power minus x plus 1 into dx. Here the variables are separable. Now perform integration. Integral dA equal to integral e power minus x by e power minus x plus 1 into dx. Let e power minus x plus 1 equals to some t. Okay, now differentiate on both sides with respect to x. Which gives us dt by dx equals to derivative of e power minus x with respect to x plus derivative of constant with respect to x. Derivative of e power minus x with respect to x is minus e power minus x plus derivative of constant with respect to x is 0. From this we'll get dt by dx equals to minus e power minus x, or dt equal to minus e power minus x dx, or minus dt equal to e power minus x dx. We can just replace e power minus x dx with minus dt and e power minus x plus 1 with t, right? Now replace e power minus x dx with minus dt. We'll get minus dt by e power minus x plus 1 can be replaced with t. Or we can write this as integral dA equal to minus integral 1 by t dt, which gives us a equal to minus log t or log mod t plus some integral constant, say c1, or a equal to minus log t plus c1. Since t equals to e power minus x plus 1, so let's replace t here. We'll get a equal to minus log of t e power minus x plus 1 plus c1, since t equal to e power minus x plus 1, right? We got a here. Therefore a equal to minus log of e power minus x plus 1 plus c1. We got a. Let's now find b dash and b. B dash is given by u into r of x by uv1 minus v1. Here we are having r of x a fraction, so we'll write the formula as u by uv1 minus v1 into r of x, which gives us u. 1 by uv1 minus v1 is minus e power minus x into r of x, 1 by 1 plus e power x, which is equals to minus 1 by e power minus x into 1 by 1 plus e power x, right? We can write 1 by e power minus x as e power x, which gives us e power x into 1 by 1 plus e power x, which is equals to minus e power x by 1 plus e power x. Therefore b dash equals to minus e power x by 1 by 1 plus e power x. Let's now find b. Using b dash, we have b dash equals to minus e power x by 1 plus e power x. B dash is nothing but derivative of b with respect to x equal to minus e power x by 1 plus e power x. Now take the differential dx to RHS, we'll get dv equal to minus e power x by 1 plus e power x into dx. Here the variables are separable. So we can perform integration. Integral dv equal to minus integral e power x by 1 plus e power x into dx. Right? Let 1 plus e power x be some p or q. Now differentiate on both sides with respect to x. Which gives us right? Derivative of 1 with respect to x is 0 plus derivative of e power x with respect to x is e power x equals to derivative of p with respect to x. This gives us e power x dx. Okay, e power x equals to dp by dx, or we can write this as e power x dx equals to dp. Now we can replace e power x dx with dp and 1 plus e power x with p. Then this becomes integral dv equal to minus integral e power x dx by 1 plus e power x. Just replace the terms. Replace the numerator with dp and denominator with p. Or we can write it as integral dv equal to minus integral 1 by p dp, which gives us integral dv is b equal to minus integral 1 by p dp is log mod p plus some integral constant, say c2, or we can write it as log p plus c2, since p equal to 1 plus e power x, and this will get b equal to minus log of 1 plus e power x plus c2. Therefore b equal to minus log of 1 plus e power x plus c2. We got a and b. Let's now write the general solution using y equals to a plus b e power minus x. Therefore, the general solution is given by y equal to a plus b e power minus x. Substitute a and b is minus log of e power minus x plus 1 plus c1 plus b minus log of 1 plus e power x plus c2 into e power minus x, which gives us minus log of e power minus x plus 1 plus c1 plus into minus minus e power minus x log of 1 plus e power minus e power x plus c2 e power minus x, or we can write this as c1 plus c2 e power minus x minus log of e power minus x plus 1 minus e power minus x log of 1 plus e power x, which is the required solution. Or we can take minus e power minus x common from these two terms simply by multiplying, dividing this term with e power minus x. Okay, now it's easy to take minus e power minus x common from these two terms. We'll get c1 plus c2 e power minus x minus e power minus x of 1 by e power minus x log of e power minus x plus 1 plus log of, you'll get log of 1 plus e power x. This gives us y equal to c1 plus c2 e power minus x minus e power minus x of reciprocal of e power minus x is e power x into log of e power minus x plus 1 plus log of 1 plus e power x. So we have seen a problem from variation of parameters method in this video. I hope you will understand. We'll see you in the next video. Until then, bye bye.